Okay, good morning, everybody. Welcome again. We will start now with Daniel Korn. He's from Red Hat, and he will show us how to automate your data center with Ansible and ManageIQ.
Right. Thank you. Can you hear me? Yeah, it works. Great. So, as Sebastian said, the topic of today's talk is automating your data center with Ansible and ManageIQ. Just a little about me. I work at Red Hat. I am a software engineer there for almost 4 years, and I'm a part of the container management R&D team. I enjoy contributing to open source, following Maccabi Tel Aviv Football Club, and snowboarding, not necessarily in this order. And just before we begin, I want to say I'm very excited to be here. And if you have any questions, there will be a Q&A session at the end, but feel free to interrupt me and ask questions during the talk. If I feel that I don't have enough time, I'll ask you to ask it again at the end. So, the agenda for today. We're going to start with the motivation for this effort that I'm about to show, the problem that we wanted to solve. Then we'll move on to present ManageIQ and Ansible. Those are two key features or two key players in this solution. The core of the talk will be a recent implementation of dedicated Ansible and implementation of ManageIQ and Ocular Ansible modules, plus demos for both. We'll then move to a short explanation about the current state of Ansible integration in ManageIQ and wrap it up with the future plans. So, motivation. The container management team that I'm a member of, its mission is to develop management solutions for container-based clustered environments, mostly based on Kubernetes and OpenShift. In a show of hands, how many of you heard about OpenShift? Oh, nice. Okay, so I don't really need to talk about it. I'll just say that OpenShift is a container application platform, a PaaS, based on Google Kubernetes. It is open sourced, and it is very useful to accelerate your development, your application development, and to manage your development lifecycle, supply with DevOps tools, and so on. There is an inner team at Red Hat, which is called the OpenShift Ops team. It is responsible for managing large number of OpenShift clusters for paying customers. Usually these customers, they want to enjoy the benefit of running container-based or OpenShift clusters without the need or the overhead to manage these clusters. So they're doing it for their customers. We've been talking with the OpenShift Ops for a few months now, and they're really awesome. We wanted to check out what are their needs to see if we can help and supply a management solution for them. So, as I said, what are the needs of the OpenShift Ops team? They need to deploy and configure OpenShift clusters over and over again, and these can be sometimes very complex. They need a fine-grained solution for monitoring, meaning they need to store metrics, then they need to define triggers on these metrics and receive alerts. They also need to use these metrics for measuring to better understand optimization, to better understand the workloads and the utilization of the clusters. For these last two, they're using Ocular. Ocular is an open source time series database by Red Hat. It is Cassandra-based. And this time series database is running inside the cluster and stores all the metrics for the OpenShift cluster. If you want to store metrics, probably a time series DB is the solution for you, where every row is basically a timestamp and a value. They need aggregated logging for all the hosts, both for the infrastructure and the applications that they're running. The Elasticsearch is also running inside the cluster. they need to have a solution for charging their customers. It is based on the measuring, on the metrics we've mentioned before. They're just attaching a price tag over these metrics. It can be CPU or memory usage, but it can also be container images. And many more needs. So obviously, we found out that automation is the key for all of these. And we wanted to help them solve this need. So let's just take a step back. And it is, in today's big companies, they're using a various range of IT platforms for their various needs. And it's becoming more clear that they need one place to look and manage all these IT environments. So we basically need one open source platform to rule them all. This is where ManageIQ enters. ManageIQ is the open source management platform for hybrid IT. It is the open source project that powers Red Hat Cloud Firms. This is the downstream version. And again, as we said, its main purpose is to allow you looking at all of your IT platforms from a single pane of glass. It also supplies you with a rich inventory, a continuous discovery for all of its entities and objects. Also map the relationships between those entities. And another cool feature is the cross-linking or cross-reference. For example, if you are running Kubernetes on top of OpenStack VMs, you can go from your container, from your Kubernetes container, through the Kubernetes node, and then reach out to the underlying VM and even to the bare metal host. ManageIQ collects metrics for performance and utilization to help you with optimization, to find unused systems, to do capacity planning, and much more. It has a cool feature of reports that you can write and then run as many times as you want. And the chargeback that we talked about before is based on these reports. Smart state analysis is the ability to inspect objects in real time. For example, if we have a container image and we want to know what's inside of it, we can run a scan that is called smart state analysis, and we can find out which packages are exactly in this container image. And also, for example, we can test it against latest CVEs using OpenSCAP or OpenSCAP. And get a mark for these CVEs. Compliance is the ability to define in a free language a list of conditions that we want to enforce, and these conditions, these policies, can also trigger actions in case they are evaluated to true or false. So if we are following the last example I gave you for smart state analysis, we can determine that for every new container image in our cluster, every time it gets discovered, a smart state analysis begins. It checks all the packages and the latest CVEs. And if this container image is marked as non-secure for many reasons, then ManageIQ will tell OpenShift not to use this container image anymore in our cluster. So it's pretty powerful. And also, the smart state analysis works for VMs and hosts and some other entities. Service catalog is a bundled list of resources that the end user can just order in a self-service kind of catalog-based. It is, he can order them instead of, for example, opening a ticket for the IT if he wants to spin a new VM. Instead of opening a ticket and waiting for the IT to answer, he can do it for himself in the service catalog. Tenancy is a key principle in both private and public cloud, basically separation or namespacing, and it also allows role-based access control. Every user in ManageIQ is a part of a group, and every group has a specific role. From this role, the users get their permissions. Automation engine is a key feature. I'll explain about it in a few slides. A key abstraction in ManageIQ, and a term that I will repeat many times this talk, is providers. This is a key abstraction. each provider is a subcomponent that talks to a specific IT platform. So we have a provider for VMware, a provider for Foreman, a provider for Ovirt, OpenStack, and many more. The way to communicate with these providers is using their native API. These providers are modular. Every provider is developed in its own repo and separated, and this is a good way to manage the life cycle, the development life cycle for this provider. But the core functionality of all providers is abstracted into the core of ManageIQ. So you get lots of repos, and each community can develop its own repos. The Ansible community, the Ovirt community, the OpenStack Neutron community. But then the core is in the ManageIQ project. The providers are divided into categories. This is not a complete list. It's just so you can get a grip of what we have. So we have cloud providers, infrastructure providers, container providers, storage providers, middleware, network, and configuration management. Now for some screenshots. Here you can see the container provider dashboard. We have two OpenShift providers there with the list of entities at the top. Right below you can see the aggregated node utilization. You can see the CPU and the memory usage. You can see them also per node. You have some network data and pod creation and deletion trends that can become useful if a pod keeps on crashing. Probably the best screen to get a bird's eye view over your cluster is the topology view. You can see here in red your OpenShift cluster. It has two nodes, one with only one pod and one container, and the other is super busy. You can see it has lots of pods, lots of services, routes, and whatnot. And this is the summary view. We have this view for every entity in ManageIQ. You can see the property of the entity, some statuses about it, and its relationships to other entities in the system. So as I said before, if you have a container that's running on Kubernetes that is on OpenStack, you'll be able to see in the relationships how it's all drilled down. Now, I mentioned the automation engine, one of the key features, which basically allows your operator to automate different tasks and operations. So, for example, if your CPU usage is more, in all the nodes is more than 80%, you would want an email sent to the operations team, or if you want to automate package update, deployments, compliance and policies, security checks, and whatnot, this is the ManageIQ way to do it. It works with running basic Ruby scripts, and you have useful methods that you can use. I know it's kind of scary. I'm also scared of Ruby, and this is why, even though I'm a Ruby on Rails developer, and this is why we want to adopt YAML as another language for the automation engine. It is relevant for the Ansible playbooks, and I'll speak about it in a few slides. A general best practice in the automation engine is using, even a design pattern, is using state machines. So you define your state, you put all your relevant methods inside this state, and then you define the state transactions. You can define that this state goes to another state B or C. You can define what happens on success, on failure, if you want the number of retries. And this is the actual logic state machine that I've written for an OpenShift cluster deployment from within ManageIQ using OpenShift Ansible project. I'll speak about it later, but this is kind of how the logic works. And think of each state as a bunch of Ruby methods. Yeah. Okay. So the question was, where can you find these state machines? Or so it's more. The answer is not kind of where you can find the state machine, but where you can find the automation engine abilities. You define these state machines in the automation engine in ManageIQ, and then In it, you can define if you want to just write a method, a Ruby method, or if you want to write an actual state. And if you go with a state, it allows you to write more states and then define the transitions. So inside ManageIQ, very useful. Have I answered? Great. So you can also access and manipulate lots of objects from the data model, not the complete data model, but you can also ask for missing ones, and it's a very powerful tool. You can use it from the UI or from the REST API, and you can import Ruby scripts for automation from any Git repository that you want. Okay, so I've been using Ansible for a few months now, and this is kind of the feeling that I get every time that I'm using it or running it, this SpongeBob happiness. In a show of hands, how many of you have heard about Ansible? Of course. How many actually used it? Wow. How many of you wrote a playbook? And how many of you wrote a module? Okay, so this talk, so probably most of you know Ansible better than I am, which is great. This is not an Ansible presentation, but I do want to explain some key principles in Ansible so that all of you can understand the rest of this talk. And if you, of course, have any questions about Ansible, feel free to ask me at the end of this presentation. I can probably show you some cool blogs and formal official documents that I used writing these modules. So Ansible is really a simple IT automation tool. It is basically what it does is communicating with the relevant hosts. They can be even your local hosts or remote hosts, and it communicates over SSH. It copies the modules, the programs themselves, execute them, and then deletes them. And I'll now try to, and by default it's over SSH, but you can also change it. I'll just explain some key principles. Inventory files are INI-like format of files. You just throw in all of your hosts. You can divide them into groups. You can define variables to your list of hosts. Playbooks are basically lists of tasks or operations that gets executed one at a time. It is written in YAML, and therefore it's very easy. You don't have to be a developer. You don't have to know any language to write them. It's just simple YAML. And modules, as said before, are the actual problems that do the job behind the scenes. They bring the system to your desired state at the end. And this kind of connects to the principle of idempotency, meaning it doesn't matter how many times you're going to run the module on the same input, it will always have the same result. So for example, if you want to copy a file, and so before the module, optimally, before copying that file to another host, it would check if that file already exists there. If it doesn't exist, then it will copy. But if it exists, optimally again, it will check if the content is the same in both files, and only if not, it would copy it. So this is the meaning of kind of, and this is kind of the meaning of idempotency. I'll give other examples for the modules that I wrote. A real-life example is the OpenShift Ansible project under the OpenShift umbrella. This project is used to deploy very complex OpenShift environments. It has lots of advanced features like NFS and registries, routes, and lots of useful things that would take someone probably a lot of time. So if you're new to OpenShift, if you want to try it, and I really urge you to do so, please go ahead and start with this project. It will help you to just run one playbook, and you'll have your OpenShift cluster ready. An example of inventory files. So at the top, you can see the three groups that we have. This is a one master, one node kind of cluster. So very simple one. You can see that we have two variables here, the deployment type and the release. But the interesting part is at the NFS group. So you can see the actual host there. And if we'll take a look at the playbook, this is an actual playbook which is part of OpenShift Ansible. So this playbook takes care of installing your NFS host. It has a list of tasks, as you can see. Each task has a name, but it's not mandatory. So you install your NFS utils, then configure NFS, restart it. Actually, this playbook has a problem. It won't restart the NFS config if the configuration hasn't changed, and it might be a problem in case the NFS config is off and you want to start it, but there was no change in the file. Anyway, this is already fixed. So after we kind of learn the key principles of Ansible, then I want to show you a recent implementation of dedicated Ansible modules. And this is the core of the presentation, so please, if you have questions, this is the time. Now, I want to go back to the OpenShift Ops team that I mentioned before. So we already figured out that we have this management solution that is perfect for them. It is called ManageIQ, and they're running OpenShift clusters. So let's say their ManageIQ instance is installed somewhere. It can be inside the cluster. It can be on a container, on a VM, it doesn't really matter. And they have their OpenShift cluster. So now they want to connect these two, configure the ManageIQ so that they will have automatically, of course, so they could just let their operators start working and monitoring this cluster from within ManageIQ. So we kind of talked to them and realized that they already know Ansible, and it is a very useful tool. So why not just write modules for them, a dedicated ManageIQ modules for them, so that they'll be able to use them instead of learning all about ManageIQ using its UI or REST API. So the Ansible modules come to automate and configure different operations and use cases in ManageIQ. It works through ManageIQ's REST API. And uses a Python-based client that we wrote and maintain. It also has a pip package you can use if you want. The link is at the end of the presentation. And the choice of Python is kind of nature, since Ansible is a Python project. The modules support SSL certificate verification, and you can define your environment variables. It is very useful so that you won't repeat every time you write the playbook, you won't repeat the same variables all over again. It is a work in progress, so we currently have only 5 existing modules, but we already have 2 pending PRs for other modules and many more coming. So I'll just mention these 5. The ManageIQ provider is used to add, update, or delete providers from ManageIQ. For example, your OpenShift provider, your Ocular provider, OpenShift, or whatever. Every time a provider is added or updated, each of its endpoints gets verified. Its authentication gets verified, and only if it is valid, then a refresh to the inventory is triggered, so that you will already have your inventory in ManageIQ, meaning all the entities from that provider will already be in your ManageIQ. ManageIQ user is, again, for adding, updating, and deleting users from ManageIQ. We are working on the ManageIQ group module, which will help with the permissions. Custom attributes in ManageIQ is basically a key value pair. It can also have a section, but this is for namespacing, so a key value pair where every custom attribute has a name and a value. This value can be a date, it can be a number, it can be a string, and I'll explain later on in the demo how they can become handy. So ManageIQ custom attributes allow you to add, update, or remove custom attributes on several resources. There are many supported resources: hosts, VMs, containers, providers, and others. The last 2 are kind of, they have the same logic. They help you assign policy profiles, which are sets of policies, and tags over specific resources. And I'll just show an example of that in my demo. And as I said before, there are many more to come concerning alerts, policies and tags, CRUD, groups, and more. So this is the workflow diagram. This is very basic. In a few slides, we'll have another one. Let's say our local host has Ansible on it, a ManageIQ module that we want to work with, and the ManageIQ API client. Now, we can configure from our local host our ManageIQ instance, no matter where it is. We just need to know where it is, or the host name for it. And we can configure ManageIQ or the providers themselves. And from your OpenShift master, from your OpenShift cluster, you get all the inventory inside of ManageIQ. This is maybe a good time to stop if there are any questions about it. Okay. Let me know if I'm talking too fast or if something is not understood. So in this demo, we're going to see how we create a new user and use this user to add a new OpenShift provider, then add custom attributes to this provider, and then assign policy profile to the provider. Okay. So this is my development environment, and this is ManageIQ. As you can see, I don't have any containers providers right now. And as you can see, the user at the top is the administrator user. Can you see it well, also behind? Not that much. Maybe turn off the front lights. Let's see if you can see this. So now I want to show you the playbook that I'm running. Can you see it at the back? Maybe with the lights closed. Yeah, the problem is that it's a recorded demo. So I'll just explain what's going on here. And if needed, I'll just go over it from my laptop live. So this is our playbook. At the top, you can see the hosts list. Basically, we have only our local host, because this is where my ManageIQ environment is. And there are two tasks here. One is the bigger one, and the second one is just a debug task. It is only to output or print the result of the last task, of the previous task, which is creating a new user in ManageIQ. Basically, you give it a name, and then you state the module name, which in this case is ManageIQ user. You give it the right parameters, the names, the password, and the group, which is super administrator group, so that we will be able to do whatever we want. And then we just fire up the Ansible playbook command with this playbook and wait for it to finish. So this is the result of the debug. You can see it successfully created the user. You can see the play recap. There were no failures. And this is, again, just a basic playbook to help you understand. Now we're going to log out and log in back with our newly created user. Powerful password of 123. And if you can see that we have our user, and go back and see that we don't have any containers provider, just so you know that I'm not bluffing you in any way. Now we want to move on and add the OpenShift provider to get a little bit messy. So here we have, again, two tasks, the second we talked about. Adding OpenShift containers provider to ManageIQ. We are using the ManageIQ provider module. We give it a set of parameters. Another best practice to worth mentioning, is that every module should have a state. It can be present or absent for idempotency. So if this provider is already present, it won't do anything. Of course, unless there is an update required in its attributes. But as you can see here, there are two endpoints that I'm giving. One is the OpenShift one, and the second one is for metrics. It is the Ocular endpoint. I'm giving the host name, the port, the authentication token. And I'm using the user that I just created with its password. And of course, you don't have to write everything down here. You can use environment variables, or you can define some variables in another file for security reasons. So we're going to fire up the Ansible playbook command with our playbook. Now this task will take a little bit longer because we need to verify the authentication for our provider. It times out after 50 seconds by default, but you can change it. So now we successfully added the provider, and you can see both authentications are valid, and you can see that the refresh, or maybe can't see, that it started refreshing the inventory. There are no failures, and we're gonna soon move back to the ManageIQ environment, refresh the page, and now we'll be able to see our added OpenShift provider. Sorry, it's taking some time. Again, development environment. And there it is. We're gonna just look inside it. And you can see all of its properties, the host name that we used. You can see that the authentications down here are validated and that the last refresh of the inventory was less than a minute ago. Up on the left, you can see the relationship between all the entities that it's got, all the list of entities. You can obviously get into each one of them. And we're going to move over to the topology view, which also take a second. And this is kind of the same view that I showed you in the first screenshot. You can actually play with everything, touch them, move them around. So we just added a provider to ManageIQ using the ManageIQ modules. Now we want to add some custom attributes to this provider. So again, we're going to edit this playbook. I promise in the last demo we're going to do all the playbooks together, so it would be quicker. We're just using the ManageIQ custom attributes module. At the top, you can see it. We state the entity type, which is a provider in this case, and the entity name. And then state present, obviously, and then the list of all the key value pairs that are the custom attributes. Now, the use case that I want to explain about is here you can see, I'm going down there, the expected number of nodes is defined to be 2. So you can actually define a compliance policy over it and make sure that once one of the nodes of this provider is not ready or not working, not accessible, then you fire up an email to the operations team. So this is one use case of how these custom attributes can be useful. Now we're just going to fire up again the Ansible playbook command and see the entire list of custom attributes we just added. We'll go back again to our ManageIQ environment, just refresh it, and you'll see a new table here for all the custom attributes that we just added. And you can see the expected number of nodes is 2. And if you're NBA fans, then I think that the MVP player for this season should be Russell Westbrook, as written there. Now, to finish this short demo, we'll just go ahead and assign a policy profile to this provider. This policy profile will take care of the OpenASCAP scan that we talked about before. So for every new image, container image discovered in the cluster, we want to schedule a smart state analysis, scan it, then run a compliance test of OpenASCAP to check the CVEs and make sure that we want to use it. So you can see that you can see here that the OpenASCAP policy here is not marked for this provider. This is just the list of available policy profiles. Now, again, just run the Ansible playbook command. And you can see that it was successfully assigned to our provider. We'll go back, refresh the page, and see the small check mark near the policy profile. Just a second. Okay, and we can actually go inside and see what policies are inside of this set. So we have, we are scheduling compliance after the smart set analysis, and the analysis happens after every incoming container image. Then we trigger the compliance, which is the open ASCAP. And obviously, I know this is kind of frustrating, but just imagine that all of these actions are running within one playbook with every new cluster that is being deployed for the OpenShift team. So we are automating this for them. So we've mentioned Ocular time series DB, and after working with the OpenShift Ops team, I kind of decided, hey, why not write some more Ansible modules for Ocular, because it's kind of hard to tweak. It has this REST API that is not that easy to use, and if you already know Ansible, then you can just look at the parameters, look at the documentation, and use it. So again, Ocular is a time series DB by Red Hat, yet another one based on Cassandra. It stores metrics. You can define certain triggers and receive the alerts. It also works through the Ocular Alerts REST API and uses a Python-based client. And again, I'm one of the maintainers, and we also are working on this P package for it so that you can use it more easily. It also supports SSL cert verification, and you can define your environment variables. Now we have 3 existing modules. Obviously, there are going to be more. I'll just explain the terms here. A trigger is basically a set of conditions that you want a certain entity or a certain metric to follow. Now, what happens if you want each one of your nodes to have at least more than 5% of its CPU free? So you wouldn't want to define it for every node. What you do is define a group trigger, which is basically a class or an object that you can instantiate from. And these instances are called members. So we have Ocular Alerts group trigger, which is for creation, update, and deletion of group triggers. And we have the Ocular Alerts group member, which is, again, creation, update, and deletion of group members, of group trigger members. Now, dampening is actually a part of the condition. They are used to empower the conditions and avoid spiking. So if you want your condition to be evaluated to true, but you don't want it to happen after one evaluation, because it might be a mistake, you can set it to a number of consecutive true evaluations, or n true evaluations out of m evaluations, or out of a certain time. So this is a dampening. Now I want to take a look at, go back to the workflow diagram and see that now we've added the Ocular modules and the Ocular client. The difference is now that the Ocular module is working through the client to define the triggers straight to Ocular and not through ManageIQ, as for what we've seen in OpenShift and ManageIQ before. You define your triggers to Ocular, and then Ocular gets its metrics from OpenShift, from the cluster. You can see the row there going down. And then the arrow, sorry. And then there's another arrow for Ocular sending the alerts to ManageIQ, and the operator can actually see them from ManageIQ and then use the automation engine to do whatever he wants, to send an email or wake up someone in the middle of the night. So in this demonstration, I'll show you how to add, again, we'll add an OpenShift provider, but this time also we're going to add a Ocular provider. It's a different type of provider. And then we're going to create a group trigger, create a group member, both in Ocular, push a metric using a script. It's going to be an artificial metric to Ocular, and then we're going to receive the alert to ManageIQ. Now, just before I'm showing you the demo, I want to mention that this is a work in progress, so maybe some of the icons are missing. This is a feature we are actually working on right now. Okay, so again, this is my ManageIQ development environment. We are in the monitoring area, where you can see I don't have any alerts at this point. Now I want to show you a new other place, which is the data warehouse providers area. And here I don't have any providers. By now we are Ansible experts, so all the tasks are in one playbook. And we're just going to go over them. The first one is adding the OpenShift containers provider. Here I'm not debugging the output because we've already seen it. You can see one of the endpoints of that OpenShift provider is actually the Ocular database. And we're also adding a Ocular data warehouse provider, also using the ManageIQ provider module that I've showed you before. It has a different type, obviously. And then we're moving to the new modules for Ocular alerts. We are creating a group trigger using the group trigger module. The tenant parameter is used for namespacing, for separation. And then we can define the group ID, but the very heart of the trigger is the conditions. So you can see we don't want the CPU to be too low, and this is in percent. It's a threshold kind of a trigger. So if the data ID, the metric that we want to use, kernel all CPU idle, is less than 5%, we want to fire up an alert. And now we want to just instantiate the member out of our group trigger. So we're using the group member module. Again, using the same tenant, and we want to link it to the group ID of the group trigger, give it an ID. Give it a description. Basically, it's just a text that we want to show in ManageIQ. And this is where we map the metric to our actual node. And we can also give it tags to use them within ManageIQ. So now we'll just fire up the Ansible playbook command. And then each task is getting executed one at a time. So the OpenShift provider was added. Now the Ocular data warehouse provider. And the last two are for the Ocular group trigger and Ocular group member. Now we'll just refresh this page and see the newly added Ocular provider. There are no icons yet, I'm sorry. And we can go into it. But let's go over to the monitoring part area. And we can see that we still don't have any alerts, which is great, because nothing happened. Now we want to generate an alert. So I'm logging into the VM and then to the Docker container that is running the Ocular instance. And as you can see here, I'll just stop it for a minute. I'm using, well, some of you probably at the back can see. So I'm running a simple Python script that I wrote that can send a metric with a certain value. So I'm sending a metric kernel all CPU idle, which kind of familiar. You may familiar from the playbook. And then we give it the value that we want, which is 4. It is less than 5. And for that reason, we're going to fire up the alert. So I'm just running this script. And now we are expecting an alert. We are refreshing the page, and still the alert isn't here. It takes a bit time, since for every provider in ManageIQ, ManageIQ starts a new worker, and currently the worker takes a bit time. You see, these are the workers before I added them, and now I'm checking the status to see if the dedicated worker for the Ocular provider is starting. And as you can see, it already started. And now refreshing the alerts area again. We can see our new alert. We have one alert from our OpenShift provider. And we can see the same text that we used, and we can see the provider name. We can see it was updated 32 seconds ago, so everything is fast enough. And you can also see some other details about the alerts, that is things that we plan to add. So this was the second demo. Now I want to talk a little about Ansible integration within ManageIQ. So in this month Red Hat Summit, it was announced that from CloudForms 4.5, Ansible Tower, which is the enterprise version of Ansible, is going to be available pre-installed within ManageIQ. The Ansible Tower is not open sourced, but Red Hat and Ansible are committed to open source it, and this effort is called the Open Tower project. If you want to take a look, this is the link. And as I said, the tower will come pre-installed in the downstream version of CloudForms, but if you want to deploy it in ManageIQ, you are able. There are very simple instructions on how to do so, and you'll be able to use your Ansible Tower provider. Now, what it gives you is the opportunity to access and run playbooks from wherever, from within ManageIQ, from your provider, which is kind of cool and useful. You can set these playbook as service catalogs for end users. You can use them in the automation. You can use them for compliance. And this is a screenshot of how it looks like in CloudForms. You can see your Ansible Tower providers. You can see data about them. The cool thing is that we have a two-way sync between CloudForms and Ansible Tower. So you can see your group of hosts from Ansible Tower in ManageIQ, but you can also use hosts managed in ManageIQ in Ansible Tower, which is kind of cool. You can see a screenshot here. And another kind of abstraction over roles in Ansible. Roles are a set of playbooks with predefined parameters and variables and maybe some other files. So you have these job templates that you can launch from the automation or service catalog, as I said before, and each of these jobs can run multiple times. Every run is called a job, and you can get some data about every run. You can see a successful run of adding a host to AWS, and it is a very powerful tool. And as I mentioned before about Ansible, we do plan to adopt YAML to another language in the automation engine. So you would need to learn Ruby. What's next? What do we plan for next? So we want to add new modules to extend the capabilities we have now. There are at least 5 that will be added in the near future. We're going to propose more advanced example playbooks for you to try. There are a bunch of example playbooks already in the GitHub repository, but we want to add more, and we will add them to the Ansible Galaxy for sure. And we want to, the most important part is probably adding these modules, both ManageIQ and Ocular, inside of Ansible project, so that once you installed you apt-get or yum install Ansible, you will get all of these modules out of the box. So just to summarize what we've seen here, we kind of saw how ManageIQ can help you manage lots of IT environments, how Ansible is a cool and simple automation tool that you can use, and combining these two can really help you with your data center automation. I showed you this one example, but we can think of other use cases. You can use the ManageIQ and Ocular modules, and also the Ansible integration within ManageIQ. Just before we finish, I want to say that we are accepting contributions. Right now, those two repos are under my private GitHub repository, but of course public, but under my name. And we plan to move them in the near future under the ManageIQ and the Ocular umbrellas. Some useful links, the slides, and the Python client we're using for ManageIQ and for Ocular. And that's it. Thank you for listening. If there are any questions.
Yep.
Hi.
Hey.
So in the thanks for the presentation. It was cool. In the context of these state machine things, you talked a lot about how you can write Ruby functions and stuff, and that will somehow interact with the Ansible things, which are Python. So I've been wondering how does this interact, and are you required with ManageIQ to run both Ruby and Python together? Is that by design, and is that cool?
Okay, so I'll try to answer. I think somehow I probably made some mess with this explanation, so I'll try to do it again shortly. The automation allows you to write Ruby scripts. You can write them as states in a state machine or not. Anyway, anything written in the automation engine is now in Ruby. No Python there. I use Python to write the ManageIQ and Ocular modules themselves, but this is another project. And I'm using Python for other scripts that I'm running because I prefer it over Ruby. But when you wanted to use the automation engine within ManageIQ, you need to write Ruby scripts. Now, I said that we plan to adopt YAML as another language in the automation engine so that you won't have to learn Ruby in order to run basic Ansible playbooks. You would just be able to write your playbooks inside ManageIQ. Until this happens, you can just write the Ruby, you can just write a template string in Ruby and just convert it into YAML and write it. I know it's not that comfortable, but it's the way to run playbooks from within the automation engine if you just want to write them there. But that's just for the meantime until we adopt YAML. Does that answer the question? Okay, so no Python at all inside ManageIQ. I only use it for outside scripts and the modules. And currently in ManageIQ, only Ruby for the automation engine. And in the future, we'll add YAML.
Any more questions?
Hey, thank you for your talk. I'm actually still might be even out of scope for this question, but just more curious how you actually define the state machines. Secondly, from the sort of system and architectural point of view of someone who wants to see what's happening in their data center, how do you reason about and see all the state machine stuff and like get a good picture? Do you have to keep a good memory as you switch tabs, or is there sort of better way to understand what's going to happen when your code runs, just for safety reasons and making sure that the right things are going to happen?
Okay, I'm going to start with the first question about the state machines. Maybe can you just repeat like the end?
Just how you define them actually,
okay,
and reason about them.
Okay, so I actually have a demo that I can show. I don't think I have enough time, so maybe I'll catch you in between. But basically, there is an area in ManageIQ that concerns the automation. And from there, you can you define your domain. And this is the way to kind of separate what you write from the rest of ManageIQ environment. So you write your domain, you define a namespace, you define a class. And in this class, you can choose if you want to start writing on this blank page, if you want to write a method or a state. When you choose a state, you then need to define other states if you want them. And it gives you the option just with a drag and drop or with drop downs, you can do both, to add the transitions between the states. Now, you can see the actual run from an Explorer view in ManageIQ. You can, but if usually we run it from the REST API, so we can see from the logs, there is an automation log, and you can see a recap of every state, what happened there, and they're kind of, they're stating if it was successful or if there was a failure and some other options. I can also show you afterwards, if you want, the implementation I did for the OpenShift installer, because we wrote a state machine there, and you can see all the methods inside of it and what happens in the different cases. But this is all inside the ManageIQ automation engine area.
Cool, very, very cool, thank you.
And maybe the other question, if we have time, I'm not sure I answered it.
Yeah, I think we have five more minutes.
Okay.
Okay, so no more questions? Then thank you again, Daniel.
Thank you.